We're going to solve linear inequalities just like we solve linear equations. Okay, so here we have negative 2x plus 14 greater than or equal to 6. So it says here, solve the following inequality, write the solution set using interval notation. Okay, so I know the program in my math lab, you may have some that are, some may be multiple choice questions, answers, I'm not sure, or at least I forgot. But I know that there's some parts. Part 1 may have you identify the graph, then part 2 may tell you to write the answer as an interval notation. Okay, all right. All right, here we go. Solve it just like as if this were an equation. But please don't start off with the inequality and then at the end it becomes an equation. Don't change the, from equal to the less than and all of that. Okay? So let's solve. We do what? Quickly. Subtract 14 to both sides. We have negative 2x is greater than or equal to negative 8. Now, let me stop here because I didn't go through all of the steps. Okay. Look at step 4. And look what I have bold. Okay. It says, with inequalities, when you multiply or divide both sides by a negative number, switch the direction of the inequality. It was okay. Just switch the inequality. Don't switch everything else, but just switch direction. So if it was less than, it becomes greater than. If it was greater than, it becomes less than. Okay, so I put a little asterisk by question 1 because it says this last step. It didn't say, now if this 2 was positive, we do not switch the sign. It says when you're dividing, and when you're dividing by a negative number, then we're going to reverse the inequality. So we're going to divide by negative 2, and we have x is less than or equal to positive 4.
That's what I had a problem with the homework too.
Yes.
That's the only thing I had a problem with. I didn't know why we had to
switch it. Okay. And I do have we don't have time in here, but, sometime I have time to show, the reason why behind it. We have a little project that we do. Yes, sir.
You said you hadn't went through the steps, but usually I do that step last.
Right. This is the step. Right. And when I say I haven't gone through, I didn't go through step 1. We do this step 2. We've done that. This is. It will always be last. Right. I don't see multiplying by a negative number, and if time permits, I may bring one in where we have to multiply by a negative number, then we reverse the sign. I don't see that a lot of times, but it's understood. Let's say we had to come up with the LCD, and in the denominator there was a negative number, then you would multiply, by that negative number, and you would reverse the sign. But I see more dividing by a negative number than I do multiplying a lot of times. And I have to say at this level, at least, okay? So, we write the interval notation. If you want to graph it just quickly, even though it doesn't say to graph, but let's go ahead. Graph it, find 4. We have a bracket at 4. We shade everything to the left. Going to the left is going out to negative infinity. And then our interval notation. Open parenthesis, negative infinity, comma 4, close bracket. Okay. All right, so we have an inequality that's a fraction, that has a fraction in it. So let's go back to what we did on Monday. 2/7 plus 2/3 is greater than or equal to x over 21. All right. It's okay if our answer ends up being a fraction. It's not the end of the world that it ends up being a fraction. But if you want to keep the question as a fraction, you're going to have to find the LCD. okay, least common denominator, and work from there. Or, like we focused on Monday, yeah, my question starts off as a fraction, but I don't want my body of the work, I don't want to work with fractions. So we're going to convert this fraction of inequality to an inequality that doesn't have a fraction by finding the LCD. 21.
We also do it with the fractions too. I don't really know how to like solve a problem with just fractions without converting it.
What do you mean by?
Like what if you have a set of numbers that doesn't have like an LCD that's, I don't know.
If everything fit, let's just say this, if you couldn't find the LCD right off the bat, such as that, whatever numbers you have in that denominator, multiply them. It'll be a common denominator, but it won't be the least.
Okay.
Okay? So, because there are some, actually I did one in my college algebra class, the LCD just didn't come off right off the bat. I was like, let's go ahead and multiply it. We had a large number we worked with, that's okay, but at least we were able to divide out. We were able to convert, okay? So if I didn't know 21 was it, I'll multiply 7, 3, and 21, and we'll have this large 3 or 4 digit number, okay? And it'll work out every time, okay? So we're going to multiply 21 to every term. If you want to place a 1 under it, you can. We want that denominator to divide into the numerator. So 7 divides into 21. 3. Take the 3, multiply it to the 2. 6. Plus. Yes, 3 divides into 21 7 times. 7 times 2, we have 14. Greater than or equal to x. Yes, because the 21s are going to divide out. Add 6 and 14. Say 20. It's okay if your answer, we have 20 is greater than or equal to x, but be mindful of how you're going to graph it. Let's go ahead and write 20 greater than or equal to x in standard form. And in standard form, it's what? X is what? Less than or equal to 20. That's why I'm saying write in standard form. If it's in the opposite written, opposite of what we're used to, you're going to have to switch. You had a question? No?
Oh, no, I got it.
Okay. All right, here we go. Here's 20, open bracket, close bracket, shade everything to the left, negative infinity. Then our interval notation, open parenthesis, negative infinity, comma, 20, close bracket. Yes.
Why is the infinity negative?
Because it's going to the left.
Oh, and if it was going to the right?
It would be positive. Yes. Question? Okay. All right, did we get this? Because I want to do another fraction. I'm going to try to do the fractional ones because I know you have a lot of those in my math lab. Number 3. We have negative x plus 2 all over 2 minus 1 minus 7x over 8 less than negative 7. So even if there is a term that's not a fraction and you have a fractional such as this with inequality, and even if it were an equation, you will still have to multiply, once we find the LCD, to every term, even to the one that's not a fraction. I have some students that exclude it. No, what you do to one, you have to do to the other. Let me repeat this rule. The rule says multiply the LCD on both sides. So if you're multiplying the LCD on both sides, you are using the distributive property. I'm not hounding the distributive property because I'm saying multiply it to every term. Yes.
7 doesn't count as what we're trying to find the LCD.
No. Only what's in the denominator. Yes. Only the denominator. So 2 and 8. LCD. 8. Yes. Times 8. Times 8. Times 8. So here we go. 2 divides into 8. Is that 4? We're going to take the 4 and we're going to multiply it to the negative x and the positive 2. So what you're saying is 4 times this. Minus the 8's divide out. Well, before we say that, because you have that minus sign, you're taking away, yes, I promise you probably have something like this. Place parentheses around it, because you're taking away 1 minus 7x, not just the 1 only. Okay? Is less than to negative 56. All right, let's distribute. We have 4 times negative x.
Negative 4x.
4 times 2, what's that, 8? Then distribute the negative. We have negative 1 plus, 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 plus. Do you understand why it's positive? A negative times this negative is going to give us a positive. Positive 7x is less than negative 56. All right, combine your x's. Negative 4x plus 7x.
3x.
8 minus 1. It's less than negative 56. Subtract 7. 3x is less than, what's that?
63.
Signs are the same.
Negative
63? Okay. Yeah, signs are the same. So we're going to add and keep the common sign. And then divide by, now, we're dividing by positive 3. Do we change the sign?
No.
Okay. But Ms. Lewis, this 63 is negative. Does that have to do anything with that definition or that statement? It says when you divide by a negative number. We're not dividing by 63. Or negative 63. We're dividing by a positive 3. So we don't change the sign. So x is less than
negative 21.
-21. And then I'm not going to do any more graphing and interval notation. We've done enough of those that you can do it. Okay?
You can't divide by numerator nowhere.
You can't divide by what now?
The numerator.
No, you can't do that. No. That wouldn't be the correct way of doing that. Now, decimals are not bad. They're not bad. Okay, as bad as fractions. Because we can work with the decimal because it's really just where you place the decimal point when it comes with decimals. Now, if you want to convert this inequality to an inequality with integers, meaning no decimals, we will still find the least common, well, some say, we could say multiple, we could say denominator. An easy way to do this, look at the place value of the last digit. It's in the 10th place. Remember, let's go back to this. This is Prep 101. okay, when it comes to multiplying by a decimal and how it shifts, okay? If you have, let's say, 0.435 times it by 10, the number of zeros that's in the power of 10 will determine how you move that decimal point over. So, since I have 1 0 and 10, I will move that decimal point over one space to the right. So I said 0.435 times 100. We move it how many spaces? 2. Okay, so if you want to, you can add 0.1x and 0.4x to get 0.5x. You can do that, or we can work with this inequality where it doesn't have any decimals, and we will multiply by, look at the place value of the last digit, and as Desi said, it's in the 10th place. So we can multiply all terms by 10. And then what it's going to do is going to shift that decimal point of the number, not to the variable. We only focus on 0.1, 0.4, 3.5. So here you will have 1x plus 4x is greater than or equal to 35. Same inequality, it's just not the decimal. You can keep the decimal, it's still going to end up with the same answer. So now we have what, 5x is greater than or equal to 35. Divide by 5. X is greater than or equal to 7. And if you want to graph it and put the end of notation on your paper, you can do so. I'm not going to do it.